Imagine if a cosmic beast capable of devouring stars and bending space itself suddenly wandered into our solar system neighborhood. Intrigued? In this video, we'll dive into the enigmatic world of black holes and ponder the chilling possibility of one drifting dangerously close to Earth. Brace yourself for a journey into the darkest depths of the universe, where the laws of physics, as we know them, no longer apply. As we approach a black hole, these simple rules of classic mechanics give way to the mind-bending predictions of Einstein's general relativity. This theory reveals that gravity is not just a force between masses, but a curvature of space and time itself. Black holes, unlike ordinary objects, warp space-time so intensely that they create deep wells from which nothing, not even light, can escape once it crosses the event horizon. These cosmic giants pull in everything that ventures too close, from space dust and asteroids to entire stars. This intense gravitational force transforms the black hole into a cosmic vacuum cleaner of sorts, altering everything in its path. Although no black holes are currently near our solar system, exploring the hypothetical scenario of one approaching is fascinating. As it continued to approach, its immense gravitational pull would wreak havoc on the orbits of planets, turning our once stable system into chaos. The ripple effect of this disturbance would be felt across the entire solar system, creating a cascade of catastrophic events. Black holes come in various sizes. Some have the mass of 50 suns, while others can be as massive as 50 billion suns. If we replaced our sun with a black hole of the same mass, nothing would change except we'd freeze, of course. But that's not the point here. The sheer scale and diversity of black holes add an extra layer of mystery to these already enigmatic objects. There are two main types of black holes in the universe. Supermassive black holes sit at the center of most galaxies. They aren't very threatening unless our galaxy collides with another, like Andromeda, but that won't happen for billions of years, so we're safe for now. The other type, interstellar black holes, could pose a real threat in our solar system. These rogue black holes move unpredictably through space, making them a constant source of intrigue and fear. Interstellar black holes form when a star goes supernova. There are two ways we might encounter one. The first is that a black hole could suddenly appear near Earth, though this is highly unlikely. The second, more plausible scenario is that a black hole could travel through the universe and pass by our solar system. In 2000, astrophysicists confirmed that black holes move through space, but the chance of one getting close to us is very small. The randomness of their paths means that, while unlikely, an encounter cannot be entirely ruled out. Most black holes form when a star at least 10 times the size of our sun runs out of fuel. The star collapses and explodes as a supernova. If enough material remains after the explosion, it becomes a stellar black hole, a super dense object from which even light cannot escape. If one of these stellar black holes entered our solar system, it would spell disaster. The first sign of trouble would be subtle changes in the orbits of the outer planets. These changes would become noticeable once the black hole was a few 100,000 times the distance between Earth and the Sun. By then, the black hole would be near the outer edge of our solar system, in the Oort cloud, a region full of ice, comet-like objects. The black hole's gravity could disturb the Oort cloud, sending comets into the inner solar system, some of which could strike Earth or other planets. If the black hole moved quickly through the outer solar system, it might not be heavily influenced by the sun's gravity. We might notice more comets in the inner solar system, but wouldn't see the black hole itself, as it doesn't emit light. We could only detect it by the energy it releases when consuming gas, visible as it nears the asteroid belt. By then, Earth's orbit would be severely affected, leading to extreme seasonal changes. These changes could alter the very fabric of life on our planet. If the black hole were massive enough, it could consume everything. As it moved further into the inner solar system, the planet's orbits would become even more chaotic. Jupiter, the largest planet, could be drawn in by the black hole. The black hole would start siphoning gas from Jupiter, creating a bright, hot disk around it. Despite Jupiter's massive size, the black hole's immense gravity would easily overpower it. By this point, Earth would be in dire straits. The black hole's gravity would cause massive earthquakes and supervolcanoes far worse than anything we've ever seen. If the black hole reached Earth's orbit, our planet would be doomed. The devastating impact would leave the planet scarred beyond recognition. Since the Sun makes up 99.9% of our solar system's mass, it would strongly attract the black hole. As the black hole approached the Sun, it would start pulling gas from it, creating a dramatic spectacle. The cosmic showdown would be a sight to behold, albeit from a very safe distance. This accretion disk, formed from the Sun and planet's material, would extend hundreds of thousands or even millions of miles from the black hole's center. The relatively tiny black hole at the core would be surrounded by a vast circular inferno, replacing our solar system with a fiery graveyard. If the black hole wasn't massive enough to completely consume the Sun, it would still disturb the gravitational fields and orbits of everything in the solar system. This disruption could be so severe that it might knock Earth and other planets out of the solar system entirely, sending them into the cold, empty expanses of space. The resulting chaos would mark the end of our solar system as we know it. The remnants of our once thriving system would be a testament to the black hole's destructive power. The intense gravitational pull of the black hole would lead to catastrophic changes. On Earth, the force would cause massive earthquakes and supervolcanoes, far beyond anything we've ever experienced. If you think Pompeii was bad, wait until you see these eruptions. We're talking earthquakes of over 10.0 on the Richter scale, and that would just be the beginning. The atmosphere would likely be stripped away, and the planet would be torn apart or sent careening out of orbit, leaving it to drift into the freezing void of space. Every city, every person, frozen in time from that point forward, forever drifting on. This grim scenario highlights the unstoppable power of black holes, where even light itself cannot escape. As we wrap up our journey through the darkest corners of the universe, one thing is clear: black holes are not just cosmic curiosities, they're potential harbingers of cataclysmic change. While the chances of one entering our solar system are slim, the mere possibility reminds us of the incredible forces at play in the vast expanse of space. If you enjoyed this dive into the mysteries of black holes, don't forget to hit that like button and subscribe for more cosmic explorations. Also, share your thoughts and questions in the comments below. What other celestial phenomena would you like us to explore? Thanks for watching, and we'll see you next time.